Now we are going to calculate moment of inertia of thin uniform rod. So for this we will consider a thin uniform rod as shown in figure. Let the rod be AB and we consider the uh, mass of this rod as m. Similarly, length of this rod as L, and the rod is rotating about the axis y dash, y dash, and we consider the axis is exactly at the center of the rod such that both sides the length will be L by 2. So this is our consideration, and now we need to calculate the moment of inertia of this thin rod for about the axis which is at center and perpendicular to length of rod. So to calculate the moment of inertia, first we will consider a small element in the rod. Let the length of this element be dx. Then mass per unit length of rod is equal to m total mass by total length, and now mass of the element that we have considered will be dm is equal to m by l into dx. We have considered a small element dx, and now its mass is m by l into dx. So this element is considered to be at a distance x from the axis. In that case, the moment of inertia of that element will be moment of inertia of rod about axis y dash will be mr square, that is mass into distance square, given by m by l into dx into x square. So the moment of inertia of that small element will be m by l x square dx. So this is the moment of inertia of the element, of the small part that we have considered. Now if we need to calculate the moment of inertia of whole rod, in that case we will do integration from point A to point B. So moment of inertia of rod about the axis y dash is I is equal to integration of the moment of inertia of the element, and integration from a to b. Now we know that the if axis is considered at center, then a position will be minus L by 2 and b position will be plus L by 2. So this integration is going to be from minus L by 2 to plus L by 2, and the value of di m by L x square dx. Now solving mathematically, m by L is outside being constant, minus L by 2 to plus L by 2 x square dx. The integration of x square dx is x cubed by 3 minus L by 2 to plus L by 2. Putting these values, L by 2 whole cube by 3 minus L by 2 whole cube by 3. So finally we get I is equal to m L square by 12. This is moment of inertia of rod rotating about an axis passing through its center and perpendicular to its length. And now this expression is for moment of inertia of rod rotating about an axis through its center and perpendicular to its length. This is the rod and this is the axis. And for this we have obtained moment of inertia as m L square by 12. But if the axis is shifted to the end over here, if the axis is shifted to another point m n, then what will be the moment of inertia? In this case, to calculate the moment of inertia in moment of inertia of the rod for the axis m n, we will use theorem of parallel axis, and this is defined as the moment of inertia through the center of mass, that is y dash, plus distance between the two axes, square of distance between the two axes plus total mass into square of distance between the two axes. that is ml square by 12 plus ml square by 4, and finally we get the moment of inertia through the axis at the end is equal to ml square by 3. And now we are going to calculate moment of inertia of circular ring. So first we consider a thin uniform ring whose mass is m, radius is r. So length of the ring, or say circumference, will be 2 pi r. And now we consider the axis at center and perpendicular to the plane of ring. So we have considered that the ring is rotating about an axis which is perpendicular and perpendicular to the plane of the ring and passing through the center. Y dash is the axis. This is radius. So mass per unit length of ring will be equal to m by 2 pi r. First step. And now to calculate the moment of inertia of this circular ring, we will consider a small element, a small portion, a small length of the ring dx, and this element is at a distance r from the axis, from the center. So moment of inertia of this element about the axis y dash will be mass of the element into square of the distance. Mass of the element is mass by length into length of the element and r square. That is, the moment of inertia of the element will be m r by 2 pi dx. Finally, this is the moment of inertia of this element. And now to calculate the moment of inertia of whole ring, to calculate the inertia of whole ring, what we need to do is to integrate di along the circumference of the ring. That is, the total moment of inertia of ring about y dash will be I is equal to integration of di over the circumference. Now putting the values, integration 0 to 2 pi r m r by 2 pi dx m r by 2 pi comes outside being constant 0 to 2 pi r dx. Integration of dx is x. Substituting the values, we get I equal to m r by 2 pi r into 2 pi, sorry, 2 pi into 2 pi r. Finally, I is equal to mr square. This is moment of inertia of ring. This is moment of inertia of ring which is rotating about an axis which is passing through its center and perpendicular to its length. Now, if the axis changes, for example, if the new axis is passing through center and parallel to plane of ring, that is, if this is a ring and now the new axis is either this or this, these axes are parallel to the plane of the ring, something like this. This is ring, this or this. We can say this one as x along x-axis and this one as y-axis, and what we have obtained earlier was z-axis. So to calculate the moment of inertia, either x or either y, we have obtained the moment of inertia along the perpendicular axis is m r square, and we need to calculate the moment of inertia along the axis which is plane to the perpendicular, plane to the parallel to the plane of the ring, that is either x or y. So for this we will use theorem of perpendicular axis. Perpendicular axis. According to this theorem, the moment of inertia through perpendicular axis is equal to the sum of moment of inertia through the parallel axes. Since the moment of inertia along x or y are symmetrical, we can write any one as another one, that is Ix is equal to Iy. So the moment of inertia along parallel axis will be equal to half Iz, that is 1 by 2 mr square. This is the moment of inertia of the ring which is rotating about an axis passing through its center and parallel to its plane.